Hello everyone. Continuing on the Keras neural network API, the problem that I want to solve today is how do you come up with the optimal number of neurons and layers for the accuracy of your model. So let's take a look at this example. You can see this data set. It's linearly separable. We will come up with a model that defines a line that optimally separates these two data sets. Visually, you can see that it's quite separable data set. So the line can be like this, line can be like this as well as I'm moving my cursor. From this data set, we'll go to a more complex data set. This is a concentric circle. We will first apply our single neuron model to it. We'll find that the model does not work. So in order for us to find the optimal separation, we will then increase the horsepower of our model by increasing the number of layers and neurons. The question is how many? So as you're watching this video, if you have any suggestions or guidance on it, please do let me know. Now let's going on some sort of a model creation. We are going to be using Jupyter Notebook for this short demo. I'm using it through Amazon Sagemaker. As you may know, Amazon Sagemaker lets you train, build, deploy machine learning models at scale. Okay, so now we are going to import some of the Python libraries, actually from scikit-learn.datasets, import make blob. Okay, then import numpy as np, then import matplot lib.pyplot spl plt. Okay, next I'm going to import some of the functions to plot the data. I'm not going to bore you by typing it, so these are a bunch of functions that are available through Jupyter sample examples, so I'm using them. Okay, then my second function to define the boundary. Now I'm going to create the data blob set using the make blob library. Okay, then plt, let's plot data, actually plot underscore data, plt x comma y, then pl dot show. Okay, so this is the data set that I showed in the beginning. It's linearly separable, and the problem that we're trying to solve is to build a model that can define the boundary between these two data sets. So the boundary can be, as I'm moving your cursor, boundary can be like this or in different ways, but it's a very clean data set. So let's start defining the model. We'll break the data into our training and test data set. So I'm using the scikit-learn again. I'm putting 30% for the test size in this case. So let's define that. So let's define the Keras model. So from keras.models import sequential, from keras.layers import dense, and then we are going to use the Adam optimizer. Okay, so now define a, so we will define a sequential model with a single neuron. Okay, and let's start training the model. As you can see, model got trained. We have 100 iterations. Epochs is 100, so it goes around the data 100 times. And the accuracy of the model is pretty high in this case. It's almost like 100% accurate. Let's take a look at the model accuracy. So the model is almost like 100% accurate. So now if you plot the model, you can now see, boom, the boundaries are very well defined between the two data sets, right? So model is able to 100% accurately define the boundary. One cluster of data on the right hand side, second one is on the left hand side. Now let's take this example to the more complex one where we have a circular data set, and then let's see if we can apply the same model to define in that and apply the same model to the different data set. Okay, so in this case, instead of a blob, now we're going to use the same code base for a more complex data set. So I'm going to create a circles over here. The rest of the code is as it is. Instead of calling, basically we need to slightly change the make circles API call. So I'm going to use this code base and then just plot it. Now that you plot it, you can see the data set is convoluted circles, And first our goal will be apply the same model. So I'm going to just run this sequentially as it is and get the model accurate, get the model running on the same data, on the new data set. Same model, new data set. You can now see that the accuracy of the model is not going more than 40-50%. In fact, let's just spit out the accuracy of the model. It's like 48% accurate. And if you just plot it, a single neuron sequential model is not good to tackle this type of data. It was good for a linearly separable data, but not for this one. So we definitely need to add more horsepower. The horsepower that we talk about in this case is adding more layers and adding more neurons to the model. So how many more layers and how many more neurons? That's the problem that I'm trying to solve. So for number of layers and neurons, I'm referencing Jeff Heaton's article. After going through this, basically coming up with 2 layers and 4 neurons. So I did that part, run the model again, say the model is training, and as you can see this time when the model ran, the accuracy is pretty high. If you rerun this script, you can see the accuracy becomes 96. And let's see how does it plot it. Basically you can see the previous plot. Now I'm going to go and run the new one, and the plot as it shows is it's not 100% there, but it's very clearly defining the separation of the two circular data sets. Thank you very much again. If you have any feedback, would love to hear it. Thank you.